Hey, so this video is going to show you how to do this type of problem. So first, what is given to us? So this right here, ooh, this right here is what is given to us, right? So the memory ID is byte addressable, memory access are to 1 byte words, address are 13 bits wide. So I'm going to explain to you what this means. So right here, we have 13 blocks, 0 to 12, and that's all it means. Now, the cache is a 4-way associative, E equals 4, with a 4-byte block size, B equals 4, and 8 sets. So here, a 1-way, 2-way, 3-way, and a 4-way. This is what it means when it's a 4-way set associative. 1, 2, 3, 4. Right? And 8 sets. What does 8 sets mean? Well, right here we have set 0 all the way to set 7, which in reality is 8 sets. And 4-byte block size. So 1, 2, 3, 4. That's what it means. 4-byte block size. So inside I have here some basic formulas. Cache equals to set times set associative times byte block size. So it's all given to us, which is a beautiful thing right here. So all we have to do is plug it into this formula, and that'll be our answer for question 1. So I'm going to write the formula here. C is equal to S times E times B, right? So we know that S is 8. We can plug in 8 times, we know that E is 4. We could plug in 4, and we know that B is also 4. So we can also plug in 4. Now if we do the arithmetic, 8 times 4 times 4, we will get 128. So this would be our answer for number 1, 128. Now question 2, find the following. Cache offset, cache set index, and cache tag. So right here I have a couple formulas. So we're going to start off by finding the block offset. So we know here that the block is equal to 4, right? So then that means that our block offset, our little b, would be equal to log base 2 of 4, which is equal to 2. And we would have 2CO, right? Now, for our set index, we know that big S, right, our 8 sets is equal to 8. So that means our little s, our set index, would be equal to log base 2 of 8, which equals to 3. And that would be our CI. Now, your next question is probably like, where the heck do I put everything? Well, here's a quick and easy way to understand where to put it. I would highly recommend memorizing this. It's just this order. I start with S, B, T. So right here, it is the set index, block, offset, and cache tag. I highly recommend you memorizing however you want to do TSB, SBT, BST, whatever you want. But I highly, highly, highly recommend memorizing this order right here. And I'm going to put it in a bubble because this is very very important. This is going to tell you where you're going to place it. So we know that we have two COs. So according to this, we're going to put our COs right here. CO, CO. Now, again, according to this, right after our COs, we're going to put our CIs. So we have three CIs. CI, CI, CI. Now, here's the thing where you have to do a little bit of math, right? Now, the remainder actually, this is our cache tag. If we do some simple math, we would know that this is 1, 2, 3, 4, 5. So it would be 5 minus 13 would be, sorry, I'm having a little bit of a brain fart here. I'm just going to use my calculator. Would be 8. Well, negative 8, but we don't care about that. So 8 would be our CT. So I'm going to do this in a different color for you, just so that you can get a handle of it. So right here, just to prove that it's right. 1, 2, 3, 4, 5, 6, 7, 8. So this is how we do this first question. The second question, my bad. This is how we find the following. Now, we're kind of lucky because it's kind of given to us, so that's really nice. So, as for part two is a little different. But it's alright, it makes everything interesting. So, first step, the first thing we have to do is convert this into binary. So 0, of course. So that line was kind of ugly. Sorry, but I'm gonna do it in this open area right here. So we're gonna convert this text into binary. Now I have the binary number conversion here, and it's gonna be given to you on your exam, so it'll make the process similar. So our first number is 0. We all know that. 0, 0, 0, 0. And now for 7, it'll be 0, 1, 1, 1. For 1, it'll be 0, 0, oops, 0, 1. And for A, which is right here, right? 1, 0, 1, 0. Now you're probably thinking like this is so much. This is so much to put. Well, the good news is that we don't even have to put it. So that's like we don't have to put it all, which is great. And we just need 13. So we're gonna start from here and pick the 13 from starting from right to left. We're not gonna do left to right. Always left. I'm sorry. Always right to left. Right to left. So we're just going to plug in these numbers, just as how it is right here. So this will be 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0. This will be what's on here. Now, because we have determined everything on the above, we can actually use that to simplify our methods. So right here would be our CO, right? Right here would be our CI. And all this, will be our cache tag. This is very important to note, right? because right here, 110, what is that telling you? Like, basically. So, sorry, brain fart. This 0110, you have to know that if there is, since this is 3, you're gonna add always a 0 in front, never behind. Always add a 0 in front. So this is 10110. So that corresponds to 6. It's asking us, this right here is asking us, go to set 6, right? So you're probably like, where is set 6? This is why we have defined the sets. So 0, 1, 2, 3, 4, 5, 6. We're going to start from right here, right? So it's asking us, go to set 6. We're at set 6. Now, what the heck do we do at set 6? Now, this is where the cache tag comes into place. So right here, numbers we have for cache tag is 0, 0, 1, 1, 1, 0, 0, 0, 1, 1. Sorry, I went ahead. Sorry. Oops. So just into the zeros, forget the ones. So that is our cache tag. 0, 0, just making sure. 1, 1, 1, 0, 0, 0. So right here. These 4 and these 4. 0, 0, 1, 1. What is this? 0, 0, 1, 1. It falls under 3. So this would be 3 and 1, 0, 0, 0. What the heck is 1, 0, 0, 0? You might be asking. 8. So now we have to match cache tag. So remember, we're working with set 6. Now we have to match the tag with tag. Now we have 238. Ooh. Now which one could it be? Well, yes, 238. Okay, sorry, I'm having brain farts all over. So now we have to find 1, 0. I mean, 1, 0. What is that? So that becomes 0, 0, 1, 0, right? Brain farts. I'm having brain farts. Is this 3 a.m. tendencies? Okay, so index 8, block offset 2. Yes, block offset 2. What the heck? You know what? It's fine. It's fine. I'm just gonna take a moment to realize what I did. Okay, so yes, we're looking for something that already has data. So we're gonna skip 0 because 0 would be a miss and there would be no data. So we go to 1, 1 with the possibility of it being a hit. So now we're gonna look for the second one because this right here is telling us look for the second block size. So I have determined here 1, 0, 1, 2. So right, we're gonna do the same. 0, no, 1, no, 2. Okay, what is going to be returned to us? Right here. EB. EB. Thanks to all this, we kind of have the information for the question too. So right here, what is cache offset? I've already said this is right here. We already did it and we've determined that it's 2. What is cache index? I also already said it, right? It's right here, set 6. It'll be 6. What is cache tag? We did that too. And it is 38. 38. It'll be yes, because we found it, right? and there's a 1, meaning that there's data inside. So it's amazing. And cache byte return. We've already determined that the cache byte return was EB because it is the second one. EB, remember, cache offset determines where we go to look for what data is returned. In this case, the data that was returned was the second value, right? So right here, we're going to put EB. Now, I hope you have an understanding of this. Now we're going to do number 2 a little bit more quicker because I am sure that you've kind of got some sort of, sorry, this is supposed to be an X. My bad. Think of this as an X. This is the hex format. Okay. This video is gonna need a lot of editing that I do not know how to do. Perfect. Okay. So we're gonna step 1, right? I'm gonna do it by steps this time. Convert to binary. Perfect, right? So you already know we have this right here, right? So our first one, there will be 1. It'll be 0, 0, 0, 1. For 6, what do we have? It'll be 0, 1, 1, 0. 0, 1, 1, 0. Our next would be E. It'd be 1, 1, 1, 0. 1, 1, 1, 0. And our last would be 8, which is 1000. Basically. 1, 0, 0, 0. Now remember, you fill step 2. I keep forgetting step 2, right? Step 2. Fill in this. Fill in address format. Oops. But we're going to fill in address format right to left. So by filling in our address format right to left, we ensure that we don't need unnecessary numbers. So basically it's plugging these in right to left. So 0, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1. Now you already know the deal because we've already identified our block offset, set index, cache tag. So I'm going to highlight it here. So this will be our CO, our cache, our block offset. This right here will be our set index. And this right here will be our cache tag. Now it's basically converting this back into hex. So 0, 0. We already know because remember our block offset is right here. So our VO is just 0, right? Now our set index, set index, I'm going to use abbreviated letters, is going to be 0, 0, 1, 0, which equals to 0, 0, 1, 0, 0, 0, 1, 0. set2. Cool. Remember that this corresponds to set. What set are we going to be looking at? It's going to be set2. I'm going to make this sparkly. Now, our CT, our cache tag, right, is 1, 0, 1, 1, 0, 1, 1, 1. Now right here we have 4, right here we have 4. So we're going to make, this chart is going to make our lives a lot easier. 1, 0, 1, 1 corresponds to B. 0, 1, 1, 1. 0, 1, 1, 1 corresponds to 7. So we're going to be looking for the tag that's B7. Okay, so I'm just going to quickly fill this in because we already have it. So again, what's our cache offset? It'll be 0. Our cache index, which is right here, it'll be 2. Talking about our set. Cache tag will be B7. Now we're going to determine if it's a hit or miss. And I'm going to do this in color purple. So now we're going to be looking at set2. 0, 1, 2. Set2 right here. Now, what are we going to be looking at? Block offset 0. No, sorry. What are we going to be looking at? Cache tag. So sorry. Cache tag. Now we had B7, right? Do we see B7 anywhere? First, no. Second, we're close, but no. Third, no. Fourth, no. So eventually, this is not going to be a cache hit, and there is no return for cache byte. And that concludes all the answers for this. Now again, so let me just go over the steps one more time. Convert into binary, fill in the address format, and just make a note for yourself. What is this on the block offset, the set index, and the cache tag? Now, first things first, this is order of precedence. We're gonna look at the set index first, then we're gonna determine, right? What this basically means, we're gonna go to the set. What set is it asking us to go to? We're gonna go there, right? Then we're gonna see if the cache tag is the same. If it's the same, now what we're gonna be returning is this right here. What is it ask? Where is it asking you to go? If it's 0, you're gonna return the first value that you see. If it's 2, you're gonna return the third value that you see, and so on and so forth. And I hope this video helps you. Bye.